Assalamu alaikum. My name is Abdullah. Today, my topic of presentation is forensic in paint industry. So, here is the table of contents. First of all, I shall tell you about the forensic chemistry. Then I'll explain the overview of the paint industry and subtopics related to paint industry like types of paints, classification of paints, manufacturing of paints, dyes, and pigments. And then I'll come to introduce you about the importance of forensic in paint industry, forensic analysis of paint, paint analysis techniques, and the case study, and the future developments in the paint in the forensic in the paint industry. Now, come to the first topic, introduction, forensic chemistry. Forensic chemistry refers to the application of chemical principles and techniques to investigate and analyze evidence in criminal investigations. It involves the use of various chemical analysis methods and instrumentations to identify, characterize, and interpret physical evidence found at crime scenes. Forensic chemists play a crucial role in the criminal justice system by using their expertise to analyze a wide range of substances, including drugs, trace evidence, toxic substances, and fire debris, among others. They employ sophisticated analytical techniques such as spectroscopy, chromatography. These techniques I will explain you in the coming slides. Now, first come to the topic of paint industry. Base paint industry is a sector involved in the production, distribution, and sale of various types of paints, coatings, and related products. Paints are substances that are applied to surfaces to provide protection, decoration, and other functional properties. The industry serves as a wide range of sectors, including residential, commercial, industrial, automotive, and marine. Overview of the paint industry. Now, the types of paints. The paint industry offers a diverse range of paints designed for specific applications. These include architectural paints used for interior and exterior surfaces in residential and commercial buildings. This category includes primers, emulsion paints, enamels, textured finishes, and specialty coatings. Industrial paints designed for industrial facilities, machinery, equipment, and infrastructure. Industrial paints often provide corrosion resistance, heat resistance, chemical resistance, and other specialized properties. Automotive paint specifically formulated for vehicles, including cars, trucks, motorcycles, and other transportation equipment. Automotive paints provide protection, aesthetics, and durability. Now, come to the manufacturing process. The manufacturing process of paints typically involves blending different ingredients such as pigments, binders, solvents, additives, and fillers. These components are mixed together to create a consistent and homogeneous paint formulation. Quality control measures are implemented to ensure product performance and adherence to regulatory standards. Market drives several factors influence the paint industry's growth and demand. Construction and infrastructure. The construction sector plays a significant role in driving the demand for architectural paints. Infrastructure development, housing projects, and urbanization contribute to market growth. Industrial and manufacturing sectors. The industrial sector's demand for protective coatings and industrial paints is driven by maintenance, expansion, and new construction projects. Automotive industry. The production and sales of vehicles drive the demand for automotive paints and coatings. These are some other techniques and regularity complaints and consumer trends. And the paint industry continues to evolve driven by advancements in technology, sustainability concerns, and changing market dynamics. The focus on innovation, product performance, and environmental sustainability will shape the future direction of the industry. The classification of paints can be classified on various criteria such as type of binder used, application method, solvent used, and the type of surface to be painted. Here are some classification of paints that I'm gonna tell you. First of all, I want to explain you based on the paints which are based on the type of binder. Binder used oil-based paints, also known as alkali paints. These are based on binder of natural oils or synthetic resins in a solvent medium. They offer good adhesion and durability, but can be slow to dry and emit strong fumes. Lactics are water-based paints. These paints use water as a solvent and a binder of synthetic polymers like acrylic or vinyl that they dry quickly, have low odor, and are easy to clean up. They are suitable for interior and exterior surfaces. Epoxy paints. These are based on a two-part system of resin and hardener, which form a tough and durable coating. They are commonly used for concrete floors, metal substrates, and industrial applications. Polyurethane paints. These are based on binder of polyurethane, which form the tough and weather-resistant coating. They are commonly used for exterior surfaces and are available in a range of gloss levels. Now come to the second part based on paint classification, which are based on the application method. First, which is a brush, which is also called ruler applied paints. These are commonly used for interior walls, trim and furniture. They can be oil based or water based and are applied using a brush or ruler. Spray paints. These are applied using a spray gun or aerosol and are commonly used for automotive, industrial, and industry application. They can be oil-based, water-based, or solvent-based. Powder coatings, these are applied electrostatically and then carried under heat to form a durable coating. They are commonly used for metal surfaces in automotive, aerospace, and appliance industries. Now come to the third point based on the types of surface. Wood paints, these are specifically formulated for wood surfaces and offer good adhesion and durability. They are commonly used for furniture, cabinetry, and outdoor decking. Metal paints, these are specifically formulated for metal surfaces and offer corrosion resistance and durability. They are commonly used in industrial machinery and outdoor metal surfaces. Masonry paints, these are specifically formulated for masonry surfaces like concrete, brick, and stucco. They offer good adhesion and durability. And there are many more specific types and classification paints, but these are some of the most common and most common ones paints which I have explained you. Now come to the paint composition. A paint composition can vary depending on the specific type and purpose of the paint. Here are the genre components commonly found in paint formulations. The first one, which is a binder. And the binder is the main component of paint that provides adhesion, cohesion, and film-forming properties. It holds the pigment particles together and binds them to the painted surfaces. Common types of binders include acrylics, alkalides, vinyl epoxy, polyurethane, and more. Pigments. Pigments are finely ground particles that provide color, opacity, and hiding power to the paint. They can be organic or inorganic compounds and come in various forms such as powders, paste. Common pigments include titanium dioxide, iron oxide, carbon black, phthaloxylene, and many others. Solvent, and the third one is solvent or carrier. The solvent is the liquid medium that keeps the paint in a liquid state for application and then evaporates as the paint dries, leaving behind the solid film. The solvent helps in proper flow and leaving of the paint. What is the most common solvent in water-based or lactic paints, while organic solvents like mineral spirits or xylene are used in oil-based paints. Additives. The fourth one is additives. Paint formulations often include various additives to enhance specific properties or performance characteristics. Some common additives include thickeners and rheology. And the second one is modifiers. These additives control the viscosity and flow properties of the paint, ensuring proper application and leveling. Defoamers, they have produced or eliminate foam or bubbles that may form during paint production or application. Antioxidants, these additives prevents the degradation of the paint due to exposure to oxygen, extending its half-life. Wetting agents and surfactants, these improve the wetting and spreading of the paint, promoting better adhesion to the surface. Biocides and preservations, these additives inhibit the growth of bacteria, fungi, and other microorganisms in the paint, preventing spoilage and extending shelf life. It is important to note that the exact composition and the proportions of these components can vary widely depending on the specific paint type manufactured and intended application. Different paint formulations may also have additional specific ingredients based on specific performance requirements or desired properties. Now we come to the two basic terms related to the paints, the pigment and dyes. Pigment and dyes are both colorants used in various industries, including paints, inks, textiles, plastics, and more. While they serve a similar purpose of adding color, there are some fundamental differences between paints and dyes. Pigments and dyes. Pigments are insoluble solid particles that provide color by reflecting or scattering light. They are typically finely ground and dispersed within a medium to form a paint or coating. Pigments offer high opacity and color strength, allowing them to provide intense and vibrant colors. They are generally more resistant to fading, weathering, and chemical degradation compared to dyes. Pigments are typically used in applications where color retention and durability are important, such as in paints, plastics, ceramics, and automotive coating. Common pigments include titanium dioxide, white color in iron oxides, and many others. Dyes are soluble colorants that dissolve in a liquid medium such as water or solvents, forming a solution or dispersion. Dyes impart color by directly bonding with the substrate molecules, often through chemical interactions, resulting in a molecule level coloration. They generally offer greater color transparency and can produce a wider range of hues compared to pigments. Dyes are commonly used in applications where color brilliance, transparency, and dyeing of substrates like textiles, paper, and leather are desired. However, dyes are typically less resistant to fading, light exposure, and chemical degradation, making them less suitable for applications exposed to harsh environmental conditions. It's worth noting that some colorants can exhibit properties of both pigments and dyes, depending upon their specific characteristics and application. And these colorants are known as lake pigments, pigment dyes. These are typically organic dyes that are precipitated onto insoluble substrate to form a solid colorant with some pigment-like properties. Overall, while both pigments and dyes are essential for providing color, and the difference in solubility, lightness, opacity, and application suitability make them suitable for different industry purposes. Now, come to the most important topic that I'm going to tell you here is the importance of forensic in paint industry, which is the main topic I supposed to tell you. Forensic analysis plays a crucial role in the paint industry by providing valuable information for various applications, including criminal investigations, product quality control, and patent disputes. Here are some key areas where forensic analysis is important in the paint industry. Criminal investigation. The first one is criminal investigation, which is a very important in this regard. Forensic analysis of paint evidence is an essential tool in criminal investigations. Paint transfer evidence can help establish links between suspects, victims, and crime scenes. By examination paint chips, residues, or patterns, forensic scientists determine the type of paint, its composition, potential sources. This information can aid in identifying vehicles involved in hit and run accidents, determining the sequence of events, and providing evidence in cases involving vandalism or assault. And the second one is vehicle identification, which is also very important. Forensic paint analysis is crucial for identifying vehicles involved in crimes by comparing paint samples from a suspect vehicle with the paint evidence collected from a crime scene. Forensic experts can determine if there is a match. This information can help enforcement agencies track down stolen vehicles, identify suspects, and provide evidence in cases cases involving vehicle-related crimes. And now the third one is quality control and product contributing. Forensic analysis of a paint samples can help in quality control and detecting product counterfeiting by analyzing the composition and characteristics of paints. Forensic scientists can determine if a product matches the specified standards or if it has been tampered with or this is a particularly important in industries where brand reputation, consumer safety are paramount, such as automotive coating, architectural paints, and industrial coating. Now, the patent disputes. Forensic analysis of a paint formulations and composition is often employed in paint disputes within the paint industry by comparing the chemical composition and properties of paints. Forensic scientists can determine if a patent has been infringed upon. This analysis helps in protecting intellectual property rights and ensuring fair competition within the industry. Overall, forensic analysis in the paint industry plays a vital role in crime investigations, product quality control, intellectual property protection, and environmental monitoring. It helps provide scientific evidence for decision-making processes and ensure the integrity and safety of products and processes within the industry. So, how this happens now come to the forensic analysis, which is a very important step in this regard. Forensic analysis refers to the scientific examination and investigation of physical evidences to uncover information and draw conclusions that can be used in legal proceedings. It involves applying various scientific techniques and methodologies to analyze and interpret evidence collected from crime scenes or other forensic contexts. Forensic analysis plays a crucial role in criminal investigation, helps to establish facts, identify perpetrators, and provide evidence for legal proceedings. Here are some key areas where forensic analysis is commonly employed. The first one is forensic DNA analysis. DNA analysis is widely used in forensic investigations to identify individuals and establish biological relationships. By comparing DNA profiles from crime scene evidence such as blood, saliva, hair with known sample, forensic scientists can determine the presence of suspect or linked individuals to the scene of crime. And I can tell you that in some Western countries, they have the full DNA record to the police station like in our country, so they can match each and everything that and can investigate the further case developments. Fingerprint analysis. The second one is fingerprint analysis. Fingerprint analysis is one of the oldest and most well-known forensic techniques. Forensic experts examine fingerprints left at a crime scene and compare them with the known prints to identify suspects or links individuals to specific locations. Automated fingerprint identification is AFIS assist in the rapid search and comparison of fingerprints in large databases. Toxicology. Forensic toxicology involves analyzing bodily fluids, tissues, or other substances for the presence of drugs, alcohol, or other toxic substances. It helps determine the influence of substances on a person's behavior, establish cause of death, or detect poisoning in suspicious cases. Trace evidence analysis. Trace evidence analysis involves the examination of small or microscopic materials found at a crime scene, such as fibers, hairpin chips, glass fragments, or soil. Sophisticated techniques such as microscopy, spectroscopy, and chromatography are used to identify and compare these materials to establish connections or link suspects to the crime scene. The fifth one is digital forensics. Digital forensics involves the examination and analysis of digital devices and electronic evidence. This includes recovering and analyzing data from computers, mobile phones, storage devices, and network logs to gather evidence related to cybercrimes, fraud, hacking, or digital misconduct. Document examination. Forensic document examination involves the analysis of handwriting, signatures, typewriting, printing, paper, ink, and other physical attributes of documents to determine authenticity, detect forgeries, or establish links between individuals and documents. Forensic anthropology. Forensic anthropology applies the principles of physical anthropology to analyze skeletal remains. It helps to determine the age, sex, ancestry, and potential cause of death, as well as reconstruct facial features or identify human remains in cases involving missing persons or mass disasters. These are just a few examples of the many subsidies and techniques within forensic analysis. Forensic scientists, experts, and specialized laboratories employ a combination of scientific method and expertise to connect, analyze, and interpret evidence in the pursuit of justice and the resolution of criminal investigation. Collection of paint evidence. And the collection of print evidence in a forensic investigation is a critical step that requires proper techniques and attention to detail. Here are some guidelines for collection of print evidence. And document the scene. And before collecting any evidence, thoroughly document the crime scene by taking photographs or videos, capture the overall scene as well as close-up images of the print evidence and its surrounding. And note that location, context, and any relevant observation. The second step is personal protective equipment. Wear appropriate personal protective equipment such as gloves, masks to avoid cross communication and protect yourself and evidence from contamination. Packaging. Paint evidence should be collected and packaged separately to prevent cross contamination. Use clean and unused containers or envelopes made of materials suitable for preserving and transporting the evidence, such as glass vials, coin envelopes, or paper binders. Sampling. There are different methods to collect paint evidence depending on the situation. Paint chips. Use a clean scalpel or similar tool to carefully scrape off small paint chips from the surface from such object or area of interest. Collect multiple representative paint chips, ensuring that each chip is separate and uncontaminated. Please place each chip in a separate container or envelope properly labeled with a unique identifier. Tape labs and swabbing, labeling. These are some more steps to involve. There's now come to the main topic which I'm going to explain you is the paint analysis techniques. The forensic analysis plays the application of various techniques to examine and analyze paint evidence. These techniques provide valuable information about the composition, properties, and origin of the paint samples. Here are some common paint analysis techniques used in forensic investigations. Microscopy. Microscopy is the fundamental technique used in paint analysis. It involves the use of optical microscopes or stereo microscopes to examine paint samples at different magnifications. Microscopy helps identify and the layers, structure, pigments, particles, binders, and other characteristics features of the paint. The second most important technique that is spectroscopy. Spectroscopy is used to identify the chemical bonds present in paint sample. It can help determine the type of binder, additives, and pigments used in the paint formulation. And the third one is subclasses is Raman spectroscopy. Raman spectroscopy provides information about the molecular composition of paint samples. It helps identify specific components and can distinguish between different types of pigments or binders. The third one, elemental analysis. X-ray fluorescence, XRF analysis is used to determine the elemental composition of paint sample. It can identify elements present in pigments, additives, or contaminants. Energy dispersive X-ray spectroscopy is used to identify the elemental composition of specific areas within a paint sample. It provides detailed elemental mapping and can help identify trace elements or contaminants. Chromatography. Gas chromatography is used to separate and identify volatile organic compounds present in paint samples. It can provide information about solvents, drying agents, or other organic components. High performance liquid analysis is used to separate and identify non-volatile organic compounds in paint samples. It can help identify additives, binders, or other organic components. These techniques are often used in combination to gather comprehensive information about the paint composition, layer structure, and other important characteristics. This selection of specific techniques depends upon the nature of paint evidence and the information sought during the investigation. And now come to the main topic, which is a very important topic. I'm going to explain you here, forensic applications of paint analysis. Paint analysis plays a crucial role in forensic investigations, which are now become the part of each and every court legal proceedings by providing valuable information and evidence in various criminal cases. Here are some forensic applications of paint analysis: hit and run investigations. In hit and run cases, paint analysis is used to link paint residues found on the victim's vehicle to the suspect's vehicle by comparing the physical and chemical properties of the paint sample. Forensic scientists can determine if the paints match, helping establish a connection between the vehicles involved. And second one is the vehicle identification. Paint analysis is employed to determine the make, model, and year of a vehicle involved in the crime by examining the layers of paint, pigments, and additives. Forensic experts can identify the specific type of paint used and potentially narrow down the range of possible vehicles. The third one is fragrance detection. The paint analysis is used to detect fraudulent alterations such as repainting or overpainting on valuable objects like artwork, collectibles, or documents by analyzing the layer of paints and comparing them to the expected composition. Forensic scientists can determine if the object has been tampered with or restored. Erosion investigation. After fire paint analysis can be employed to identify the presence of excellence residues left on the fire damaged surfaces. Analysis of the paint and its physical and chemical properties can help determine if an accident was used to start or spread the fire. The fifth one is accident reconstruction. In traffic accident investigations, paint analysis can assist in reconstructing the sequence of events, and by analyzing paint transfers and their patterns, forensic experts can determine the relative positions and movements of the vehicles involved, helping to establish the cause and liability of the accident. Overall, paint analysis is a valuable forensic tool that can provide crucial evidence and support investigations in various criminal cases, including hit and run incidents, vehicle-related crimes, fragilities, erosion, burglary, and accident reconstruction. Now I'm going to tell you the case study, which is a very important in this regard. Certainly, here is some case study that demonstrate the application of forensic science in a criminal investigation. The case, the murder at a Greenfield Manor. First of all, I shall do the background. Greenfield Manor is an upscale residential estate where a prominent businessman, Mr. Richard Greenfield, was found dead in his study. The initial investigation revealed that Mr. Greenfield had been shot and killed. The prime suspect was his business partner, Mr. Andrew, who had a history of conflicts with the victim. Okay, the conclusion. Based on the forensic analysis, the prosecution built a strong case against Mr. Andrew Stevens for the murder of Mr. Richard Greenfield. The ballistic evidence in bloodstream pattern analysis, DNA matching, gunshot residue, and fiber analysis collectively presented a sampling argument that linked Mr. Stevens to the crime scene and the murder weapon. The jury found Mr. Stevens guilty of his first-degree murder and he was sentenced accordingly. The case study demonstrated how different forensic techniques, including bloodstain ballistic analysis, pattern analysis, DNA analysis, gunshot residue analysis, and fiber analysis, were employed together. Evidence establish connections and support the investigation and prosecution in murder case. Here I would like to tell you some real examples of paint analysis. Here are some examples of real world cases where paint analysis plays a significant role in forensic investigation. The first one is Green River Killer. In the investigation of the Green River Killer, Gary Ridgway paint analysis was crucial in linking him to the crime scene. Forensic scientists analyzed paint samples found on Ridgway's truck and compared them to the paint sample recovered from victims' clothing. And the analysis revealed a match, providing important evidence connecting Ridgway to the murders. Art forgery. Paint analysis has been used to detect art forgery. In the case of the forger Hanway migrant who created fake Vermeer paintings, paint analysis helped expose his depiction. Scientists analyzed the chemical composition of the paints used in the fogged artworks and compared them to the non-Vermeer paintings. The disappearance in the pigments and leaves revealed that the paintings were not authentic. BTK killer, Dennis Rader, also known as the BTK killer, was captured in part due to paint analysis. In one of his crimes, Rader had tied up and strangled a victim, leaving behind a ligature made from a unique type of cord. Forensic scientists compared the paint on the cord to paint samples found in Rader's possessions, and the analysis showed a match, helping establish his connection to the crime. And similarly, comma setting bombing was the one of also the real-time examples of this case is automotive clean investigations. Paint analysis is frequently used in hit and run cases and vehicle related by comparing paint samples and the scenes of the victim vehicle. Forensic experts can establish a connection and identify the source vehicle involved in the incident. These examples illustrate the diverse range of applications for paint analysis in forensic investigations, including linking suspects to the crime scenes, identifying failed artworks, connecting vehicles to the crime, and providing evidence to solve complex cases. And what kind of future developments that are here in this regard, I'm going to tell you. The first one is advanced spectroscopy techniques. Spectroscopy techniques such as Raman spectroscopy and infrared spectroscopy are commonly used in paint analysis. Future advancements may include the development of portable and more sensitive spectroscopic instruments, allowing for rapid on-site analysis and detection of even trace amounts of paint components. And the second one is imaging and microscopy enhancements. Improvements in imaging and microscopy techniques can aid in visualizing analysis of paint samples. High resolution imaging such as scanning electron microscopy and atomic force microscopy may provide more detailed information about the surface topography and chemical composition of paint layers. A nanotechnology application. Nanotechnology holds potential for advanced paint analysis. Nanosized sensors and probes could be used to detect and identify specific paint components in future, enabling more precise and targeted analysis. And the fourth one is data integration and artificial intelligence. And the fifth one is non-destructive analysis. Non-destructive techniques for paint analysis are desirable to minimize sample damage and preserve evidence integrity. Future advancements may focus on the development of non-destructive methods that can analyze paint layers and compositions without need for sample extraction or destruction. It's important to note that the field of forensic science, including paint analysis, is continually evolving, and future advancements will likely depend on technological innovations and research breakthroughs in related scientific disciplines, which is the main has been the main principle throughout the human history. Now coming to the conclusion. Conclusion is that the forensic paint analysis is a branch of forensic science that involves the examination and analysis of paint samples in criminal investigations. It plays a significant role in linking suspects to crime scenes, identifying vehicles involved in crime, detecting fragments, and providing valuable evidence in various cases. Here is a summary of forensic paint analysis that I'm going to tell you in some few words. First of all, purpose. And the purpose of forensic paint analysis is to examine and compare paint analysis between suspect and a vehicle and object to the crime scene. It involves studying the physical, chemical, and microscopic properties of the paint and its layers. Techniques which are discussed earlier, summarized for you is that some forensic scientists use a range of techniques which include Raman and infrared spectroscopy, chromatography, elemental analysis, and etc. Application which I discussed with you is that paint analysis is in various criminal investigations, including hit and run, which I explained in briefly. Vehicle-related crimes also discussed, progress, arrogant investigation, and many more like this investigation reconstructions analysis process come with the four analysis process. During paint analysis, forensic scientists collect paint samples, which I also discussed the processes in very detailed interpretations. As forensic scientists analysis interpret their findings based on the similarities or difference in color texture, layer texture, and additives and other characteristics of the paint sample. The goal is to determine if the samples originate from the same source, such as the same vehicle, the same paint batch, or the same object. Importance of forensic chemistry in paint industry, which is the basically last topic of my today's presentation. And forensic chemistry plays a crucial role in the paint industry by providing valuable insights and ensuring product quality, compliance, and safety. Here are some key aspects highlighting the importance of forensic chemistry in paint industry. First of all, quality control, which also forensic chemistry techniques are employed to assess the quality and consistency of paint products. Analytical methods such as chromatography and spectroscopy can be used. And the second one is product development and formulation. Forensic chemistry assists in the development and formulation of new paint products by analyzing chemical composition and properties of different pigments, binders, and additives. Chemists can optimize formulations for desired characteristics such as color, durability, coverage, and drying time. Third one is raw material analysis. Forensic chemistry is used to analyze raw materials used in paint production. This helps identify impurities, contaminants, or or dirty performances. Fourth one is compliance and regularity standards. The paint industry is subject to the various regulations and standards related to safety, environmental impact, and labeling requirements. Forensic chemistry helps to paint manufacturers comply with these regulations by conducting chemical analysis to ensure that their products meet the required certification and limitations for hazardous substances. Identification of counterfeit or substandard paints. Forensic chemistry techniques can be utilized to identify counterfeit or substandard paints by comparing the chemical composition and properties of suspected counterfeit paints to genuine products. Forensic chemists can detect discrepancies and help protect consumers from inferior or fraud products. Paint failure analysis, and these are paint failure analysis. In case of paint failure analysis or defects, forensic chemistry plays a vital role in investing the root causes. Chemical analysis can identify factors such as improper formulation, inadequate curing, contamination, compatibility issues, providing insights for remediation and prevention of future failures. Overall, forensic chemistry is essential in the paint industry for ensuring product quality, compliance with the regulations, investing in failures, and providing scientific support in legal matters. It helps to maintain integrity, reliability, safety of paint products, benefiting both manufacturers and consumers. Thank you so much. This is all from my side, which I try to explain very best in my own words in the forensic in the paint industry. Hope you understand. Thank you very much.